Hi guys, welcome back. This is Professor Hank, and in this video I'm going to start a three-part series on some architecture related software design patterns. Right? So what I'm going to show you is how you can go about structuring your code. Right? So we'll take a look at three different approaches or three different software design patterns. One will be MVC, that'll be in this first video. Then in the next video we'll do the delegate pattern, or also known as the delegation pattern. And then finally we'll look at a layered architecture. Right? So I should probably start off by defining what a design pattern is. In software engineering, a design pattern is a general reusable solution to a commonly occurring problem within a given context in software design. A design pattern is not a finished design that can be transformed directly into source or machine code. So with software design patterns, what you have is a strong suggestion or guideline about how you should go about doing things. And so if you're not sure how to arrange your code or how to divide it into separate modules or different design entities, then a design pattern having to do with architecture could be very useful, right? So these are suggestions for how you go about doing things. Okay, so let's talk about the model view controller design pattern, and I'll go over the basics of it, give you a brief introduction, overview, and then I'll finish off with a very simple Java program example, right? I mean, it's going to be trivially simple, but I like trivial simple examples because they really get the noise out of the way and can let you just focus in on what's being discussed. So anyway, so let's talk about model view controller design pattern. All right, so what's the motivation behind this particular approach to writing your software? Well, I mean, if you think about it, an application has a few basic parts to it. Right, so you can think about the data that's being used. That's always a good starting point when writing a program. You know, how are you going to store your data? How's it going to be represented? How are you going to interact with it? That sort of thing. But you also have a user interface for using that data. Now, logically, makes sense that the data is separate from how the user views it. Right? And so if that's the case, then that display of data should be separate, and it should be able to be developed independent of the other part, right? So I mean, how you display data, how you store data, those are two different things. So they should be able to be, the code for that stuff should be able to be developed independent of each other. They should be separate units. They should be decoupled. Is the thing, and it makes sense. I mean, because if you think about, you know, say a website that shows you baseball statistics, right? Well, that website could be storing data, a ton of data, right? Home runs, number of wins for a team, career stats, all that kind of stuff. Now, different users of that website are going to be interested in viewing that data in different ways, right? So one user might want to view the total home runs by a team hit in 1962, right? Another user might want to view the total number of home runs hit by a certain team for 10 years, right? So, you know, how the data gets presented to a user and how it's actually stored, two completely different things, right? So the counterexample of having all of this stuff separated out and decoupled would be, hey, let's just take all of the logic, all of the data that's being stored, how it gets presented, we'll throw it all together. Let's just vomit everything up into a main method or a main function if you're talking about C++, right? Just forget about it. We'll just have a million lines of code all in one function or all in one method or all in one class, right? Rather than trying to modularize this thing and separate, you know, the different responsibilities of the program into different design entities. So, you know, what we want to aim for is to have certain entities responsible for certain things. That's where we want to go. So the MVC pattern, MVC stands for model, view, and controller. And at a high level, what's happening is that this particular pattern outlines three broad design entities, right? That you can organize all of your code around, all of your classes, all of your functions, all of your whatever. So the first thing, M, stands for model, and any classes that have to do with data storage and for setting and getting data is going to fall underneath the umbrella of the model, right? So that's that part of it. So the next design entity, V, stands for view. So any classes that have to do with displaying data to the user or getting data from the user or interacting with the user in any way, that's going to fall underneath the purview or underneath the umbrella or within the realm of the view design entity. So example for model, if you're writing classes to manage a database, you would say that those belong as part of the model. If you're going to write classes that are going to present buttons to the user, text boxes to the user, drop-down menus to the user, that would fall within the purview of the view design entity. Okay, now what about the controller? The controller is going to sit in between the model and the view design entities. It acts or behaves kind of like the glue that holds those two things together. It's what separates them and allows the model and the view to be independently developed. So the controller is responsible for, interpreting what the user is doing with, the user interface and changing that or translating that into operations on the model. So, for example, a user types in their name into a text box and then clicks save, right? Well, the controller is going to have to retrieve that information from the view and then send it on to the model for permanent storage, right? And then let's say that the user clicks a button to display a graph of the home runs, right? Well, then the controller is going to have to ask the model, please give me all of the home run totals, and then I will organize that into a nice neat little graph and send that off to the view components so that way the view can draw the graph on the screen, something like that. So user's going to click some buttons, user's going to interact with the menu system, you're going to get other types of inputs. That would all take place within the realm of the view. A button would be a member of the view. A menuing system would be a member of the view. Other types of inputs from an external actor, such as a human being, user, trying to interact with the system. Anything that they're interacting with, view. Anything that's responsible for storing data and providing that data on command, model. The controller is the logic that holds the two together, interprets the clicks, asks the user or asks the model for data to service those clicks. Okay, so here's kind of a graphic that illustrates this. The view and the controller are interacting directly with each other. User's doing something, the controller is detecting that anytime that the UI has to be updated as a result of maybe a calculation, computation, user doing something, well then the controller tells the view to update that. And if data has to be stored long term, well then the controller is going to make sure to tell the model entity, hey, here's the data, make sure you store it. Now the controller doesn't care how the model is storing the data, don't care. It's just interacting with the model through some kind of interface. If it's a very simple example like I'm going to show you, then that interface on the model is just going to be a set of public methods, right, that the controller is going to invoke. Similarly for the view. View is going to provide a set of, if it's a very simple example, a class that is going to have a bunch of methods that the controller can invoke. You'll notice in this diagram or this graphic that the view and the model, there's no direct communication between the two. which would mean, at least at a very basic level, that the view has no reference to anything within the model itself or to the model itself. So they can't invoke each other's methods or send each other messages. There's no communications going on between the view and the model. Any communication between them has to go through the controller. The controller has a logic that's controlling how those communications happen. So some example implementations, mapping MVC to classes. So the view could be some kind of a swing widget or widgets, so frames, buttons, text fields, etc. The controller could be made up of all action listeners that are executing their logic in response to a button being clicked. And the model could be some class that just stores, maybe it's a linked list class, or maybe it's a class that is responsible for managing a database or some file, or maybe a socket or something like that. Okay, so the model and view, they are completely separate. They're decoupled, right? And they get linked to each other by the controller. So here's some mechanics for it. So one approach would be, for setting this up, would be have a class that instantiates the model, instantiates the view, and then you have a controller that is going to be able to store references to the model and the view. And so if the controller has references to the model and the view entities, then it can invoke their methods and therefore control the model and control the view, right? So, here's one way that you could think about the execution. The view, some entity within the view notices some event, maybe mouse click, button click, typing into a text edit, drag, whatever. The view is going to invoke the correct method on the controller. So if we're talking about an action listener, somebody clicks a button, there is an on-click event that happens, and then that method that is implemented in the action listener that fires. That's where the logic is, right? And so that action listener would then turn around and invoke a method on the model. So you have message passing going on between these three entities, where something's being generated in the view, going through the controller, and then into the model. And it can work in the reverse too. If something in the model changes, then the controller can update the view. So if the user, for example, says, all right, well, I'm going to click on a button, I'm going to type my name into a text field, click on a button, and then that would cause a listener in the controller to respond, right? Because that listener has been linked to a button. And so it would then ask the text edit box or the text box, hey, give me what you have. What's in you, what the user typed. And then it would turn around and invoke a method somewhere in the model and say, hey, model, store this name, right? And then as a response to that storage, it could be time to update the screen on the view, right? Let the user know, okay, everything's been saved, right? So you've got these three different pieces all working together, view and model not directly interacting, controller standing in between, right? So there can be some issues here that could impact your decision whether or not to use the MVC pattern. One is that it can be slow. Not as slow as other architectures, but if you're clicking a button that invokes a couple methods, invokes a method in the controller has to do its thing, it turns around and invokes methods on the model then returns a value to the controller then invokes a method in the view to maybe update with that value that was returned from the model. So you got data moving around these different layers, as it were. And that's just a simple example where maybe there's only 3 classes involved. But there could be many classes involved. And so you have a lot of message passing going on, a lot of method invoking going on. So those are function calls with all the overhead of function calls. So that definitely can be an issue. Now, it can be common for input and output to be intermingled in a GUI. And so when that happens, then the view and the controller can become really closely related or really tightly coupled. And we'll see that one way of dealing with that to speed things up if you have this constant communication, it might be advantageous to go with a different pattern known as the delegate, which we will talk about in the next video, right? So right now, what I'm going to do is I want to go ahead and show you a simple implementation of this using Java. Okay, so to speed things up, I've already set up a basic package structure, and I'm going to go through each one of these packages and explain this here in a second, or right now. So what I have set up is I've set up a folder called controller, model, and view, right? And so each one of these folders is going to correspond to a package in my Java code that's going to contain all of the classes that are related to that design entity. So anything that has to do with interacting with the user, I'm going to put into package view. Anything that has to do with storing data, I'm going to put into package model. And then the guy linking those two together, that's going to have the actual logic for the application. It's going to be inside of package controller. Now, this example is going to be really simple, right? So each one of these packages is just going to have one class that's going to be able to show you, just the moving parts, right? This is going to be a stupid little command line interface app that just going to do something simple, like ask the user to enter a number, we'll store the number, we'll give them the number back, that sort of thing. And then I have a driver package that's just going to contain my driver class. Okay, so let me go ahead and start off by doing the model. I think that's the easiest one to start off with. So you can see here in the code, got started here, package model, and this package is just going to have this one class. And so for this simple example, all I'll do is have this class store an integer, right? So anything that's in the model is going to be storing data. And so for this example, I'm just going to have one class. It's going to store a regular old integer, and it's going to provide services for storing that integer and for retrieving that integer. So let's add a setter method, and we'll add a getter method, and that'll be it. That'll be it for my model, right? Because again, we'll keep this really simple. So I've got a class in my design entity called the model, and I just call the class model, and the class itself is an entity within the model entity, but really simple, really simple. Okay, so let's go take a look now at the view, right? So in the view package, I'm just going to have one class, just again keeping it simple. And what this is going to do is this is going to be responsible for all the interactions with the user. So I might want to be able to prompt the user for some information, right? So if I'm going to have a prompt, then I might just call this, make it public, right? Public void prompt, right? And so I'll take as an argument some string, p for prompt, and when this method is invoked, it's going to interact with the user. It's going to display something to the user. So it's going to display whatever was passed to it, right? So p. Okay, now I might want to be able to retrieve some input from the user, so that would be useful. So how about get input, or maybe I'll just call it input. How about that? And so what's going to happen here is that this is just going to ask the user, or it's just going to read from the keyboard, read responses from the user. Okay, so maybe something like this, where I'll just set up a scanner, and again keeping it simple here, just so you can see how everything works. And we'll go ahead and return s.nextInt. Okay, so something really simple. So this class right here, our view, is simply going to be able to prompt the user for something and then read something from them, read an integer from them and return it. Okay, so simple enough. Okay, now let's go to the controller. The controller is going to be the glue that holds everything together. Okay, so what my controller is going to have is a reference to model and to view, right? So this is the only class that's going to have references to the other two, because this is the only class that can directly communicate with the other two. This is how we're going to enforce the decoupling, the strict decoupling of the model of the view. Since they don't have references to each other, it's impossible for them to directly communicate. It's impossible for them to message each other. And by that I mean it's impossible for them to invoke each other's methods. But since the controller is going to have those references, it will be able to invoke their methods, and therefore it will foster the communication between the two. So let's include a constructor, right, for my controller. So model M and view V. And so what we'll be able to do is we'll be able to instantiate any type of model, any type of view, and pass it to this controller to control both the model and the view. So this allows us to switch out different user interfaces and different methods of storing data independent of each other. And so long as the view and the model maintain their public interface in terms of the name of the methods, their parameter lists and whatnot, controller don't care. And it doesn't matter what their internal implementations are, don't care at all. Just needs to know what the public interface is. As long as that public interface stays consistent, we can swap in views and models at will. Okay, so let's go ahead and set this view equal to V, and we'll set this model equal to M. And then from there, we'll implement the logic of the app within the constructor here. So what's it going to do? Well, first thing we'll do is we'll ask the view to ask the user for a number, right? So we'll say v.prompt, right? And why is that going to work? Well, that's going to work because we have a prompt method in our view, right? So let's go ahead and do that. So v.prompt, enter a number, right? So that string is going to be displayed on the screen because that's what the view does with its prompt method. Okay, so we'll do that. And once we've asked the view to show them that prompt, then we'll ask the view to get their response. v.input, right? So what's that going to do? That's just going to try to read an integer from the keyboard and return it. And then that'll store that into a variable I. Now once we've got that number, the controller then says, oh, well, now it's time to store that number. So then it'll tell the model, go ahead and store I for me. Really appreciate that. And then once it's stored it, maybe we want to show that number back to the user, right? Maybe we will retrieve that number from the model. Right? We'll get that number back, and then we'll give that back to the user. Right? We'll say, all right, you entered this number, right? And we'll show it to them on the screen. Let's see here, and we will put that on its own line. Okay, and then we could also confirm that the number actually got stored. Right? So if you prompt, your number was stored successfully. Successfully. Can I spell successfully correctly? Apparently I can't. Is that right? I don't even know. We'll go with it. Whatever. Backslash n. Okay. All right, so that's just going to be the simple logic of this program, and those are all the moving pieces, right? So what I need now is I need to go get my driver running. And so my driver is going to simply instantiate a controller right? And remember what the controller takes as arguments, right? It takes its constructor takes a model and a view as arguments. So I'm just going to say new model, and I'm going to say new view, right? Now, what I'm doing here is I'm going to use the model and the view classes that I imported from those packages, right? But let's say that I had different types of models, different types of views. Well, I could just as easily have instantiated those instead, right? And thanks to polymorphism, if I use interfaces, well, I could be doing all kinds of crazy stuff. But for this example, we got something simple, so we'll just leave it at that. So I think I'm ready to test this. So let's give it a try. All right. All right, so let's do it here. I gotta specify my class path. Okay, and the name of my driver class is MVC. Okay. Let's see, I got, it's not public model. Okay, so set X, not public. Oh, let's go back and fix that. There we go. So public, forgot my methods here, or my access specifiers. So to make sure that on view I put them in there too. I did, cool. Controller, cool. All right, so let's try again. Sweet. All right, so now let's go ahead and run it. Oops. Cool. So we're running it and enter a number. How about 99? Your number was stored successfully and you entered this number 99. So let me put the code side by side and then just summarize what just happened, right? So I've got, oops, wrong window. So I've got my directory set up, right? And I've got my different pieces of the pattern explicitly split up, right? Controller, model, view. Everything that has to do with controlling the application is part of package controller. Everything that has to do with storing data for the application is in package model. Everything that is responsible for displaying stuff to the user is in package view. So my driver program, which is just simply instantiating the controller here, well, that's in package driver. So remember what the view does, just provides a method. The service is, hey, I want to display stuff to the user. And then one of the other services it provides is to read something written by the user. Okay, and remember what the model does. All it does is provide the service for storing the data and then for returning the data, and it's part of the model. Okay, now controller, it's responsible for fostering communication in between the two and also incorporating the mainline logic for the application. So it's got the references to the other two pieces. The other two pieces are completely and utterly independent of each other. They don't communicate directly. They don't have references to each other. They can't directly invoke each other's methods. The only one who can invoke each of those guys' methods is the controller, because it controls everything. And so what does this simple app do? Prompts the user for the number. And so this is a message being sent to the view, and that message is prompt the user. And what are we going to prompt the user with? Well, we're going to send some data along with that message and say, well, show them enter a number. And then after that, we send another message to the view, get an integer from them. And so in response to that message, the view returns back an integer, which we put an I. And so then we went ahead and sent a message to the model by invoking a method on the model class. And we said, here, store this information for me. And in addition to the message, we pass some information. I want you to store something. Store what? Store the integer and I. Right? And then once we've done that, we send a message to the view saying, hey, put on the screen your number was stored successfully. And then after that, we send a message to the model saying, hey, give me the number that you've been storing. And that data was returned to us, which we put inside of the variable j here. and then we sent a message to the view that said, hey, put this on the screen. You entered this number, and that number is what was returned from the model. Okay, so the model and view completely decoupled from each other. They could be independently developed, right? So I could, I could change set X, right? I could change set X to where maybe I'm storing all the integers into an array or something, right? The other components don't care so long as the public interface, those methods and their signatures, so long as they stay the same, controller don't care, right? It's data hiding, implementation's hidden. And the view certainly don't care because the view isn't contacting the model at all anyway, right? So long as the public interfaces of the model and view stay the same, then the controller can work with any of them. And it's really easy to be able to swap out different versions of the model, different versions of the view. Okay, so I think that's everything I'm going to have for you in part one here. So to summarize, what is a software design pattern? Strong suggestion, how you can organize things. In this video series, I'm going to go through and show you 3 suggestions. One is model view controller. The next one we'll do is the delegate or delegation pattern, which is basically combining the view and controller into one entity. And then we'll finish off with a video on layered architecture. And with MVC, view, anything that has to do with this interacting with the user belongs to the view entity. Model, anything that has to do with storing data, belongs to the model entity, right? And then the controller, the logic, the mainline logic, and gluing the model and the view together, anything that has to do with that, that's going to belong to the controller or fall underneath the purview of the controller entity. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up. And if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.